Hi, I'm Chris, and thanks for tuning in to the Freelance Robotics YouTube channel. Join me today as we perform some welding, some plasma cutting, and some plasma gouging on the Blue Dragon Framework self-programming robotic system and showcase its manufacturing capabilities.
We're plasma cutting some 6mm thick steel flat bar into pieces at 0 degrees, 30 degrees, and 45 degrees, and then welding them back together again using a few different methods. To perform these welds, we're using one of our training methods called marker training. How that works is you take a blue marker pen and you mark exactly on the part where you want the robot to weld, and then you perform a table scan using the robot's camera and it will weld along that blue marker. To perform a marker scan, you first need to add in a new part, give it a name, and then train the part and then start the robot. From here, you can then click Scan Table on the top right hand side and the robot will perform a table scan and create a CAD model of your part. From here, on the right hand side, you can click the Training tab, the marker, select the color that you're using, then click Detect Marker. This will perform another set of scans, which you can see then create our operations along the part where we place that blue marker. Once you're happy with those operations, then you can perform a simulation run, which will show you the robot's exact path that it's going to take as it performs these operations. You can then make adjustments to the robot path depending on what you need to achieve. The other method of training that we will be using and showcasing is called hand training. Collaborative robots like this universal robot allow the user to put them into a free drive mode. This lets the user move the robot into position by hand, and using Framework you can record a set of points. These points will then be used and straight line operations will be created between the points to form the welding path. The robot is now performing a cold run. And a cold run is when the tool attached to the robot isn't powered on so that the user can validate the robot's position before performing a hot run and turning on the tool. Once we were happy with the robot's position for each of the operations, we then performed our 0 degree, 45 degree, and 30 degree plasma cuts. Take a look at the quality of the cuts that this hypertherm plasma cutter produces. So we've now moved the freshly cut pieces across from the plasma cutting system over to the welding system, and we're going to be performing a butt weld between the 0 degree cut part and the 45 degree cut part. Again, we're performing a scan on the part, and we're going to be using hand training on this section to perform this operation, putting one point at the start of the weld and one point at the end of the weld. We were really happy with the quality of this weld, but as the parts are so thin, there was some burn through on the back of the part. But we'll fix this by performing a gouge on the underside of this part and then re-welding in the gouged out channel. We were performing some test gouging to dial in the settings on the robot, and here's a view of the underside of that part and why it requires gouging and re-welding. So bringing the part back over to the welding framework system, we can see that the part in reality doesn't match its position on the screen. Now this is a problem because the robot will go to the wrong position when it goes to perform its welds. Luckily, Framework has a feature called Scan Realignment where it takes another scan of the part and realigns it on the screen to its real position, bringing the operations along with it. This is a clip of the cold run operation that we've generated to fill in that gouging channel with welding material. And this operation will finalize our manufacturing process on this part. Now we have set down two pieces of the steel flat bar, each cut at 30 degrees next to each other, creating a 60-degree channel between the two. This big of a channel will require multiple welds, so what we're doing is performing a multi-operation layer generation, where we're generating 3 welds and 2 layers. Here are the results. Keep in mind the plates are very thin, so it's difficult to do multiple welds. The final operation that we'll be performing is between the two pieces of the flat bar that were cut at 45-degree angles. Placing these two together end to end creates a 90-degree angle, and here you can see the cold run of the operation that's been trained for this specific part. Here are the results of this operation, and the weld looks fantastic.